This is a review of the Rosewill Glacier Series continuous 80+% bronze certified semi-modular power supply. Here you can see the power supply. It's semi-modular because the motherboard cable that plugs in, which is a 20 and 24 pin connector, and the extra power connectors for the CPU are permanently attached to the power supply. In addition, you're going to get the AC power cord. You're going to get two PCI connectors to run your GPU units with. Here you have two connectors or cables to run your SATA drives. Each of these cables has 5 connectors, so you can power 10 different SATA drives. And here you have two Molex connectors. I use these to power up fans and accessories, for example. In addition, you're going to get an instruction manual. You're going to get 3 cable ties and 4 mounting screws to mount the power supply. This bag here was the bag that the power supply actually came in, so that was just a nice little accessory. And then here you have a bag here that all these cables came in. My suggestion is to save this bag, because what will happen is you may not use all these cables, and you only want to install the cables you need. The less cables in the computer, the better the airflow, and the better the cooling process of the fans working on the CPU, the memory, and your GPU cards. Take the extra cables, stick them in this bag, and save them. Matter of fact, if you're building a computer and you have additional hardware left over, screws and brackets and all, put them in the bag also. It's just nice to keep all that stuff together. This power supply comes with a 3-year warranty. The power supply itself is rated to operate on 100 to 240 volts AC, and it automatically adjusts to the voltage. In addition, this type of power supply has automatic power factor correction. Power factor is an issue with power supplies because they're full of coils and they're full of large transformers, and the transformers and coils phase shift the current out of phase with the voltage. Inside of these, they use high quality capacitors, and they phase shift the voltage and current back in phase, and that improves the efficiency. What happens is, if the power factor is really bad, you're going to draw excessive current and not use it to power your computer, but you're simply going to generate heat inside the box, and also you're going to generate heat of the wiring of your home. This power supply has a single 12-volt rail. It's also supplying you the wiring with these PCI connectors here to use SLI or crossfire technology to use multiple GPU cards. That includes here, you're going to get 4 different connectors of 6 plus 2 pin connectors to hook up different GPUs. Here you can see an extremely large 135 millimeter fan with an auto fan speed control. So the warmer the power supply gets, the faster the fan is going to run. That helps keep the noise to the minimum, and the fan only speeds up when it's needed. Here you can see the back of the power supply. Like I said, there's no switch here to switch between voltages. The power supply does it automatically. You'll see the connection for the power cable, a power switch, and you'll also see the 4 mounting holes that you use the screws in to mount it into your case. You have to remember, a CPU can draw from between 130 and 140 watts if it's overclocked and really pushed. A GPU could draw 150 watts, and if you got 2 of them, that's 300 watts. Here you can see the power ratings on the different buses. There's a 3.3 volt bus that's rated at 20 amps, a 5 volt bus rated at 20 amps, a plus 12 volt bus rated at 70 amps, and here you have a minus 12 volt bus rated at 1/2 amp. Then you have a 5 volt standby bus rated at 3 amps or 15 watts. This is what is called a semi-modular power supply. Semi-modular because the heavy power buses that come out, that go to the motherboard and the CPU, are permanently wired into the back of the power supply. It just means that this is already fixed in place. It doesn't really make any difference. This is still a great power supply. Matter of fact, I've used a lot of these on different computer builds and servers. This big connector here that you see is the main motherboard connector. It's a 20 plus 4 pin connector. These 4 pins here on the end will actually separate off. That way, depending on the motherboard and the CPU you use, you can use the 20 or the 24 pin cable. You also have a couple of connectors here that you can hook up. One of them is an 8-pin connector, and the other one's 2 4s. These are to run additional power to the CPU. In addition to the wired-in cables, you're going to have these extra plugs here where you can plug in the cables. This is your PCIe port for your GPUs. And then here are your ports that you would wind up using for your hard disk drives, your SATA, and your floppy controls, and also for your Molex connectors that you might use to power additional case fans, for example. The first thing I do when I buy a new power supply, whether I'm sticking it on the shelf for a spare part to help somebody in the future or building a computer, is I plug in the cables and I check out every one of these ports and every one of the cables that comes with the unit. The reason for that is that now's the time to find a problem. Who wants to build a computer, turn it on, and not have it come on? Worse yet, find out that something's wrong and it damages your computer, your CPU, or your memory. Now's the time to find those issues, and I strongly suggest that you follow a process like this. This is a computer power supply tester. I've built a lot of computers, and so I use this to test them before I install them. What this does is it checks all the voltages from all the cables, and it gives a digital readout of the quality of the power supply. It doesn't check the full load, but it does give you a readout of the voltage tolerances. If I press this, you can see the green lights light up. That means all the buses are working. It also tells me that I have the 5-volt bus working at 5 volts, the 12-volt bus working at 12.1, the 3.3-volt bus working at 3.3, the minus 12-volt bus is working at 11.7, and the 12-volt bus working over here for the CPU is working at 12.1. It also tells me that I have a standby 5-volt system. It's working at 5 volts, and that's important because that's what powers the mouse, the keyboard, to help you boot up your computer. In addition to that, it tells you that the computer started up and had good power, PG means power good, in 430 milliseconds. So that's a pretty good response. I always believe that an ounce of prevention is worth a pound of cure. I also don't want to damage expensive components. I check every power supply this way. In addition, I also take the computer and actually build it on top of the table, and I do that without using the case. I take the motherboard, I mount the CPU, I plug in the memories, I put on the cooling system, I plug in a DVD drive, for example, I plug in my boot drive, and when I turn it on, I actually check out the entire system and install my operating system onto the boot drive before I even put it in a case. You might ask the question is, why would I waste the time to do that? I'll tell you what, it takes about 15 minutes for me to plug it together or less, and to be honest with you, now's the time to find out that some component or key issue doesn't work, and then when you put it together, it's going to work perfectly. It's a good stopgap for having to take the computer apart. In addition, taking all these wires and running them in through the computer and putting them in place and tying them down is a lot of work. You want to do it right, and you want to do it right the first time and be done with it. So I'm going to check out all the components before I route all the cables. Later on in this video review, I'll talk about the advantages of using modular power supplies, and I'll show the inside of one of the computers I built that uses that. I wanted to talk a bit about using a modular power supply and why I think it's very important to do. To me, when you build a computer, you want to dress the wires in very nicely to improve the airflow through the computer. That's what keeps things cool. That's what keeps your CPU cool. That's what keeps your GPUs cool. It lets the fans do the work and move the air around without it being blocked by a lot of cables and wires always located in the wrong place. The thing I like about modular power supplies, you only use the wires that you want to use. If you're only going to want to have one GPU card, you only plug one of them in and use it. If you go back and expand your computer and add a second card or other peripheral cards, you can plug in more cables and use them to power up your devices. Modular power supplies are easy to use. You plug in the cables and you route them the way you want to route them, make it a nice clean installation. You can see here I have the cables tied together so that they're nice and dressed so that the airflow can move around. Nothing's in the way of these GPU fans, for example. I've got it all pulled away and tied down. This is why I always focus on using modular power supplies in the designs I build. I like them a lot. I think it's the best way to go. This is a good power supply. All the outputs were working. I'm going to rate it at 5 stars. This review was done by JJ I'd like to tell you that I received a sample for test and evaluation, and I didn't promise a review, but I promised if I gave one, it would be fair and honest.